what we're looking at today is line of best fit. And this here are the general steps for finding the line of best fit. We want to create a scatter plot of the data, so we want to plot all the data points. Sketch the line that most closely appears to follow the trend given by the data points. There should be as many points above the line as below it. Choose 2 points on the line and estimate the coordinates if they don't actually go through a point. They don't have to be the original data points. And then write an equation based off those points. Well, that's a little bit subjective because the points that I choose or the line that I choose could be different than the points that Allie chooses or Callie chooses because it depends on how we want to set the thing up. So really, if we did this the way that this says, we could end up with many, many, many different lines depending on how we draw it and the points that we choose and so on and so forth. So I don't put a big emphasis on this here because, again, this is very dependent on how you set the thing up. Or at least not so much the points, because we'll all have the same points, but how we draw the line. So I don't put a big emphasis on this. Now, you don't have to write this down. This here, the line of best fit is the line that lies as close as possible to all the data points. Many technologies have a linear regression tool that will help us be able to actually draw the line, actually have it. Now, the correlation coefficient is denoted by R, so this R value. Now, you don't have this specifically written in. I'm not going to make you write it in because it's not going to be that big of an issue or deal. Now, if this value of R is in between -1 and 1, the big thing is is it close to 1 or -1? Because if this value of R is close to 1 or -1, it means the data or this line is a good fit for the overall data. We do have a line that best represents all the points that we are given, so we know that that line can be used to anticipate or predict other points along it, what should be expected. Now, it's not going to be the exact value because, again, it's close to the data, close to it. So it won't be the exact values, but it'd give us an idea of what to expect or what we expect should happen. Now, if R is near 0, the points do not closely relate to any line. There's no correlation to any of it. It's not a good fit. It will not closely or represent the data at all. And really, we want to be within 0.05. So if it's between -0.095 and -1, then it's really good. If it's between 0.95 and 1, then it's really good. It's good data. We can assume that the data that we have for it or moving forward will be a good representation of the overall set of data that we have, and we can use it to figure out or not guess, but approximate what will happen, what could happen. And that's what we're really going to be looking at today and using the graphing calculator to figure this out. So that's what we're going to be doing is we're going to be using the graphing calculator to calculate a linear regression or finding the line of best fit. So the first thing we want to do is, well, we need to turn the graphing calculator on. So we turn the graphing calculator on. I got it. So you might need a graphing calculator. The first thing we're going to do is hit stat. So once you turn it on, you want to hit stat, and you should get something that looks like this here. Stat, S-T-A-T. There's a button that says S-T-A-T, and you should get a list like this here. Once you get this here, go on and hit enter. Stat and then enter. And we have this list, yes? Now we want to enter the information in. Now in your note sheet, there should be an example 4 at the top using a graphing calculator. So it might be on the next page. Should look something like this. Now, as you see over there on the right side of the page, it says femur length X and height Y. We're going to enter those values in. So we're going to enter the X values or the femur length values in the first column. So we can start off with the first value is 40. And then we'll do 45, 32, 50, 37, 41, 30, 34, 47, and 45. Once you get all those numbers plugged in for the femur height, let's go on and plug the numbers in for the height. So we'll in the other line, we want to type them in the exact descending order. That it shows. And when we get done typing those all in, they should line up evenly. So the last one in both columns should be 45 and 182, and they should line up exactly. One shouldn't be higher or lower than the other. We got all that typed in. And what this is doing is it giving the calculator the numbers that we want it to use to figure out this line, to figure out this equation, this line of best fit. Any questions on this here so far? And when we do this, or have this here, and it gives us the line of best fit, we want that R value to be either close to 1 or close to -1. If it's close to 1, it gives us a positive slope, it's going up. If it's close to -1, it's giving us a negative slope, it's going down. So any questions on this here so far? Okay. Well, what we can do next is hit second mode or second quit. We want to quit out of that window because we have all the data plugged in and we're back here. Second quit mode. M-O-D-E. Yep. So now the R value is not turned on automatically because if it's been reset or it hasn't been turned on, it's just not on. It does not start on. And what it features and what needs to be turned is the diagnostics. Because if diagnostics is turned on the calculator, it will give us the value of R, how closely the data is represented by the line. So to find that and make sure that's turned on, what we need to do next is hit second, 0. Second, 0. And this is the catalog. So the catalog, like any catalog, is going to list every single possible thing in the calculator, just like the Sears catalog listed every single piece of clothing or items that they sold. The same thing is true here. And what we need to go down to is diagnostics on. Now there's two ways to get there. One is going to be clicking the down arrow, going through the A's, B's, C's, and going all the way to D. The other way is, well, if you notice up in the top corner where the A is, because normally that shows up if shift or alpha is hit. And what that's telling me is that alpha is selected. So the green letters. So if you notice, all the green numbers or letters above the symbols are all letters A, B, C, D, E, F, G. So if I find D, so matrix, and I hit that, well, that took me straight to the D's. I didn't have to go through A, B, or C. It took me straight down there because I know diagnostic starts with A, D. So it got me a little bit closer. We still have to scroll down. Detect diagnostics on. So we still do have to scroll down some, but we want to scroll down to diagnostics on. Has everybody been able to find that? Once you find it and have the arrow next to it like this here, go on and hit enter. We good? Okay. So we're here, hit enter one more time. And it should say done. Yes? So what it's telling us is that the diagnostics has been turned on. If it was already on, you're good. It's not going to turn it off. It's still going to stay on. The only way that I can turn it off is either resetting the whole thing or going back in there, because if you notice the one above diagnostics on was diagnostics off. So we can turn it off. But it turned the diagnostics on. Okay, now let's go and find that line. So if we go into stat, and again, we're wanting to figure out the line. Yes, we're wanting to calculate it. CALC, calculate. So all this in that second row, all of those in that list are functions that we can calculate. It can do for us. Well, linear regression is what we want. So we're going to scroll down to number 4. So you should have that highlighted and go on and hit enter. So it should say LIN, REG at the top, AX plus B. Now the first one, X list. So it's asking for the X variables. Question? Question? Okay. So this here is all the X variables. So the ones that we put in L1 are listed there. So we can hit enter. And there we go. And hit enter. We can go down there because L2 is the Y list, which is already good. Now I went down to store Reg equation. So what this is asking is the equation that we get, do you want it to store it somewhere? Now, Y equals is where we'll graph. Don't hit that yet or at all. But this, or not yet. We'll do that later. But if we were to graph, the Y equals button is where we would put the equations in that we wanted to graph. It will graph it for us there. So what we could say is if we wanted to store the equation so that we can see the graph, we would want to store it in one of the Y equals spots. Now to do that, we can hit alpha, trace. So you'll need to do it in that order. So we'd hit alpha, trace. You'll need to hit alpha first. Otherwise, it's going to send you straight to a graph. Now, it pops up this list here, Y1 to Y0. And these are the different spots we can have. So I could input multiple things. Now, what we'll do is we'll just hit enter and put it in Y1. So in the equation slot, there's 10 of them. We put it in the first one. We said whatever the equation of the line is, we're telling the calculator to take that equation and store it in there for us, so we don't have to copy it over. Go on and hit enter. If I can hit enter, and enter. Yes. Window 6. Let's look at. Yeah. Window. Clear. Second quit. Stat. Cut. Linear. Second stat. L1, L2. Alpha. Go to. Oh, okay. Or stat. Edit. Okay. So let's look at the data. So 34, 47, 45. Yeah, so it didn't like the fact that those weren't lined up. Okay. So we have all those listed in, and this is what they gave you, yes? Now, if you notice that the equation here, y equals ax plus b. A is where our slope is, b is where the y-intercept is. So what this is telling us is that the slope of this line is 2.603570555. Well, again, like I said yesterday, and I think I said this yesterday, a lot of these here, when we deal with kind of more real-world scenarios, the numbers won't always be nice. We won't have a nice slope of like 1/3 or 2, or these nice kind of numbers that work out well. We'll end up getting numbers like this here. They just aren't nice at all. And also the y-intercept is not 65, it's 64.9968207.4, and it continues on. It is bigger numbers than that. But the big number that kind of we're focused on is R. R is 0.9945. Can we say that this equation gives us pretty reliable data? Well, yes. It's going to closely relate the line that we have. So it will get us close. So go on and hit y equals. And you should get something like this here. Yours is probably going to be a little bit wider, or it could be something exactly like this. Well, if we notice the slope, because it said on the other one, where we saw the multiple 5s, it stopped. Well, here, 148, there's more numbers there. It's a very long decimal number. And the same thing can be said for our y-intercept, because you don't have to scroll over. I'm just scrolling over so that y'all can see this. There's a lot of digits. Because that's even longer than the one they gave us on the first page. So, again, that's helpful for us because we don't have to type that in. Makes it a little bit easier. Okay. Now, it does say that this does closely represent the data, so why don't we look at it so that we can see it for ourselves in a graph. So there's going to be a few things that we need to do that. Now, first, let's scroll up so that the cursor is blinking over plot 1. You want it blinking over plot 1. And whenever you get that, hit enter. So if you notice now, instead of it, the blinking was around the plot, now the plot itself is blinking. That means it's turned on. And what that will do is it'll plot the points that we put into L1 and L2. It'll plot those points for us so that we can see where they're at. Now the second thing we need to do is hit graph. Did y'all show anything? No. This here is the standard plot. And what this does is it has, for the x-axis, it's from -10 to 10. The y-axis is from -10 to 10. Does any of the points we put in here, are they between -10 and 10? Are any of those points between -10 and 10? No. The smallest value we have is at 32, I believe. So none of these here are going to fit. So we do have to change that. Now there's two ways we can do it. The first is through zoom. There's different ones here that we can zoom the scale. It'll do it for us. Now if the graph doesn't look like we had there where it's in the dead center, zoom standard, Z standard is the one to hit. Because it'll reset it to -10 to 10 on the X, -10 to 10 on the Y. That's where it will go back to. There's another one down low called zoom fit, which will fit or try to fit the data as best it can. But that's not, none of these are what we're going to use. What we're going to use today is window. Now what the window does is you are telling the graphing calculator, this is what the x-axis needs to be or contain and show us. This is what the y will contain and show us. So for the x-axis, the minimum value that we want is 25. So we want x min to be 25. We want x max to be 55. And we're going to go by a scale of 3. Now the Y minimum that we want is 120. And the Y maximum that we want is 210. And we'll take a scale of 9. So what we've done is we've made it so that those two sets of points, the Y values will all fit into our graph. They will show up. The X values will all be contained. So we made it so the X and Y, all of them will show up in the graph. We have that. Okay. We're good with this here. Once you get that, go on and hit graph. I'm going to stay here for a minute. Make sure everybody gets it down first. We're good? Yep. Do I have something like this here? So each one of those squares or points are the points that we put in from the beginning in L1 and L2. And the line that they drew through it is our equation, the graph of the line of best fit, that best fits or represents the data. Yes, ma'am. Okay. Let's see. Let's see, go to, because what someone did was put that there.
Shiny. What? I did everything right. No, you didn't. Well, why are you asking me?
There's a good chance someone else used it and put that down. Yeah. So, because there is some data that's stored in these from previous classes, because they like to put, once you all start getting used to these, I've had other classes that will fill all 10 Y equals with just random numbers, or in some of them we will look at table, so it will do a table, and I've seen some of them that sent the table all the way up to negative 10,000, so they literally sat there and hit the up button tons and tons of times to get it way out there. So some of it gets set up that way. So that's what that could have been. But this here is the data that we have, and it's for femur length. Now, I'm going to throw the paper on the floor. So our femur length is the x-axis. Now say, because we have 40, 45, 32. So 50 was the highest value. Now, if we wanted to know somebody's overall height, if their femur length was, say, 55, well, that's not listed in this here, is it? Well, no. What we can do, if you notice up at the top above trace in blue, it says calc, C-A-L-C. Let's go second trace. So it should say calculate, and it says value 0, minimum, maximum, intersection, dy dx, or integrate, or the integral of f of x dx. Well, we just want to know a value. So if we're given a chart, we can say second trace value. Now we said femur was 55, or whenever x is 55. So I can say value and tell it x is equal to 55. Hit enter. So y would be 208.1932. So if they had a femur length of 55 centimeters, their height would be 208 centimeters. So we can actually calculate the values from here. We can predict what it could be. Well, will a person with a femur length of 55 centimeters be 100 or 208 centimeters tall? Could they? Well, yes. Will they 100% be? Well, no, because again, this is predictions. Because if we look at all the points that go around this line, well, only maybe 1 or 2 really are on top of that line. The rest are either kind of close above it, close below it. So these lines best represent the data, but they're not always going to be 100% accurate. It gives us an idea of what to expect. Not what is certain, but what to expect, what we can anticipate will happen based off the information that has been given to us so far. So when they talk about population growth, this is what they're talking about. Or if we're talking about data and it's not a straight line, they're using stuff like this here to predict what we think will occur. And that's all we're going to do today, because I wanted to show you this here. Now, before we get finished, completely finished, what I want you to do is hit second. Is everybody second? Plus 7, 1, 2. Second plus 7, 1, 2. And that's it. And we are done for